Okay, so the first four problems are just basic either u substitution using normal functions or trig functions, or either some arc sine, arc cosine type problems. So I'm just going to do one of the first four. I chose number 2, which is u substitution with trig functions. So in this problem, I would set up my u, and this is the u substitution, not like the integration by parts. This is just one of your basic forms that we've studied from the beginning of the year. So my u is going to be my tangent of 4x. My derivative then of my u is secant squared of 4x times that 4. And I want it to be times 8, so I'm going to multiply both sides by 2. So 2 du will equal 8 secant squared of 4x, which is what I need. So I have the 2 times my u to the 1/4 du. My antiderivative here, I'm going to add 1 to my exponent, which would be u to the 5/4, and then dividing, which would be multiplication by the reciprocal. And of course, I need to substitute my u back in, which would make it 8/5 tangent of 4x to the 5/4 plus c. Now, starting with number 5 and on, you will have to do separation by variables, which is your u v minus the integration of v du. And so for this one, I would set up my u as the ln of x, because of course we know we do not have an antiderivative for ln of x. So my du here would be 1 over x dx. That leaves my dv as my 1 over x squared, and my v as the antiderivative of that, which is -1 over x. So if I did my u times my v, I would have -1 over x ln of x minus the integration of my v, -1 over x, times my du, 1 over x, dx. I'm going to simplify this here. This is a minus a negative, so I can change that. And then it's going to be 1 over x squared. So I will have -1 over x ln of x. My antiderivative of this is of course x to the -2. So I, just like I did up here, already actually taken that derivative. So it's going to be a -1 over x plus c. Now in your answer key, they did rewrite this part of it because it has a common denominator, so they just have -1 times ln of x minus 1 all over the x plus c, but both of these answers would be acceptable. The next one's number 11. Now for this one, you are going to want to use that natural log as your u, and that will leave just the dx for your dv. So my u is going to be that natural log of that whole group x plus 1. My du will just be the 1 over the x plus 1. My dv is just dx. And my v, remember the antiderivative of this is just a 1 in front of it, so my v is just x. So then when I plug that in, my u times v, well, that's just x ln of x plus 1 minus the integration of my v du. So x times 1 over x plus 1 gives me this dx. Now for this integration, I am going to have to use the method of division because this is 1 over 1, so my degrees are the same. And so if I did that, I have x plus 1 into just my x. It goes into it one time. x plus 1, remember I'm adding the opposite here, that's a 0. So you actually get a negative 1 as your remainder, minus 1 over x plus 1. So when I take that integration, I leave this alone, x ln of x plus 1, minus, and now I have the integration of 1 minus 1 over x plus 1 dx. Of course, again, I leave this first part alone. The uv never changes. X ln of x plus 1 minus the antiderivative of 1 is just x. And I am subtracting here. Think about it as distribution here, so distributing that negative. So this is actually a plus. And the derivative of this piece is the natural log of x plus 1, and then plus c. So this then would be your final answer for that antiderivative. All right, so this one is going to be a little bit different because I'm actually going to have to do the separation of variables twice here. So I'm actually going to use the u as the ln of x squared. And for my du here, I actually have to use the chain rule. So remember the chain rule requires that I move that 2 in front, 2 ln of x to the first power times the derivative of ln of x, which is 1 over x, which leaves my dv as just dx. And then my v then would be x. So when I do my integration here, it's u times v, so I have x ln of x squared minus the integration of v du, which is 2 ln of x times 1 over x dx. Now I can cancel these x's, this x and this 1 over x, but that still leaves a 2 ln of x as my antiderivative. And so once again, I have to use u substitution or separation of variables here. So I'm going to say my u then is going to be 2 ln of x. My du is going to be 2 over x. My dv is going to be the dx, and my v is just x. And so when I put that back in here, I'm going to leave this part alone, x ln of x squared minus, and now I'm going to do separation of variables again, u times v, which is just the x 2 ln of x minus the integration of v, which is x du 2 over x dx. And then finish this out, leaving this part x ln of x squared minus, and I'm just going to write this a little bit neater, 2x ln of x. Think of this as distribution, so now I'm going to say plus. These x's cancel, so I'm really just taking the antiderivative of 2, which is 2x plus c. And this would be your final answer here for this integration.